Hi, I'm Abul Arabi from SIGGRAPH, Texas A&M University, and I welcome you all to our presentation on augmenting everyday objects into personal robotic devices with Dr. Zeun Kim from SIGGRAPH. Current technological development has brought robotics into manufacturing and industry automation. In our homes, we are blessed with smart devices such as IoT thermostat, smart switch, IoT light, and many more. However, robots are found in our homes in the limited scope of vacuum cleaning, lawnmower, or entertainment. Whereas they can do much more, such as serving food, moving the trash away, as well as accessibility and elderly care. So, the question is, why aren't we living with the robots yet? Well, to answer that question, let's have a look at some critical factors. Our everyday life is full of versatile tasks, such as pouring water, taking care of the laundry basket, beating eggs, etc. And currently, we don't have a robot for each and every task. Besides, unlike passive objects, robotic devices are complex and hard to fabricate. For example, in order to create a self-shaking salt and spice jar, a user needs to have a multi-top robotic arm, then equip electronics, and finally do the kinematic programming, which is complex and requires several domain-specific knowledge. Moreover, off-the-shelf robotic platforms are expensive, cannot be reauthored or retrofitted easily, and not ubiquitously available. Instead of speculating any futuristic robot that will magically carry away all of our works, we are inspired by prior ACI works for supporting physical tasks that enables novices to augment their passive everyday objects into a smart one without the requirements of domain-specific knowledge. We can start with today's existing devices and slowly add on intelligence, manipulative ability, and function. Start small and augment large. Thanks to the ongoing development of 3D printing technology that can allow us augment everyday objects, and combined with end-user programming, we can automate our everyday tasks. We aim to enable anyone to develop their personal robotic devices by adding mobility to their passive everyday objects. From a simple demonstration using cell phone, our toolkit fetches all the design requirements, creates 3D printable mechanisms, makes a list of required electronics, and finally generates the code to operate the device. Now, let's have a look how our toolkit works. First, the toolkit takes an image of the target object and a motion demonstration from the user using a cell phone. From the captured image, the toolkit detects the target object and fetches a 3D model from the repository, which eventually delivers the geometry information. The recorded demonstration is then classified and quantified. Currently, the toolkit supports horizontal, rotation, and lifting motion with different combinations. At this point, the toolkit has geometry information, types of required motions, and the motion planning information. Based on these, the toolkit generates mechanisms using our parametric design library that is coherent to the size of the target object. Then, the motion planning information is coded into an Arduino sketch that can be directly uploaded to an Arduino board. After fabrication and assembly of the components, the passive object is transformed into a smart one. Now, let's have a look how such augmented devices can automate our everyday life. Such mechanisms can be reauthored for a new use case scenario. Defined motions can also be stacked to adopt new capabilities. A future combination of these augmented devices can further ease our everyday life. Let's have a look. With the ongoing rise of smart devices, the energy requirement also increases. In a similar manner, we can allow end users to fabricate their own energy harvesting mechanisms that can harvest electrical energy from their daily kinetic interactions, such as from twisting doorknobs, actuating dryers, or accumulating small energy from multiple iterations and use it later. We believe such augmentation can transform today's passive everyday object into smart devices of the future. Thank you for being with us throughout the presentation.